Several years back, I got involved in a somewhat passive way in a program that was a big project that brought together climate scientists, computational experts, and economists. And I was kind of a passive observer to that, trying to figure out what the best ways that one might contribute. And that project itself really never got off the ground for me, but it did introduce me to the topic. And I became completely convinced that this is an area in which, first of all, had its social relevance. Second of all, uncertainty was a central part of it. And third, it required computational modeling. And the challenge of putting these things together on a problem that had such obvious social relevance and to draw on some of the other work I'd been doing to think about the uncertainty made it very appealing to me. I tend to take a more patient view of this. The political climate is what it is, but it doesn't have to stay that way. And there's ways to have impact longer term, and I really view that that is and should be our ambition here. And like others, I might be depressed by the fact that there's some circumstances where kind of more social scientific approaches seem to be diminished or not valued. I'm presuming that's more of a short-term phenomenon. So I think I'm optimistic that there's scope to have impact, longer term, and I think that it's kind of on us to try to now make this, to show people, to kind of show academics as well as other people why research like this can be relevant. I don't know, what do you think, Mike?
Yeah, I mean, the thing that I really like about it is that what a model, gives me at least, is sort of a toolbox to play with and to think about how to address these questions. So for me, I've never been a big sort of, opinion person or political person, but what I have enjoyed is if you have a toolbox, you have a framework, and you sort of have these models, then you can say, okay, here's what we've done, here's how we're analyzing it, and it just gives structure to something that, rather than just having this open-ended argument, it gives you the structure to say, okay, here's the tools or the assumptions that we've made, what makes sense, what doesn't, and then we can sort of say here's a foundation from where to think about the questions rather than kind of coming from opposite sides or our own sort of personal beliefs. It sort of depends. There's sort of this whole different array of models that exist. I think typically they'll have sort of two central components, which is just a very central kind of economic framework that says if you take some inputs, you produce some outputs, and then you'll have some kind of climate component, some type of side that will say here's emissions or here's how these emissions are going to impact the economic outcomes. Now the complexity of that varies, I think, by a lot of models. And just by the nature of what the models do, some will have important components like we need to think about economic growth or we need to think about how severe these climate damages can be. But it seems that there's, this is true of a lot of models, there's not really a framework that addresses all of these things. I think there's, within these frameworks that have been really nicely put together, there's still become clear there's a lot of channels that we aren't really getting at, which is sort of the point of what we want to understand is that there are a lot of channels still to be understood, and I think we have a lot to say about different components that aren't yet there, that things like risk and uncertainty that can really matter in meaningful ways.
So one thing that I think individual researchers maybe aren't incentivized to do, but what's important for us is to take their particular approach, their particular model, the details, the specificity of that model, and do a systematic comparison to what other people are doing. And the way we come at this is say, well, we're not, researcher X's work is kind of interesting, researcher Y's work looks interesting. There's differences in what they're doing. Do they matter? Do they matter in important ways? We've had to open the door on what we actually get from evidence. Does that evidence really tell us a lot about those different ingredients and the like? And so we only know how to address these kind of sensitivity type of analyses by putting on the table questions like what should the social cost of carbon be, or like what's a good policy to pursue, and then what ingredients matter and which ones don't, which we have to think harder about going forward, and which don't we? So this conceptual framework for understanding the limits of our knowledge, uncertainty, and its ramifications we find very valuable going forward. I guess my conjecture would be yes. Certainly Nordhaus's work got a lot of attention. And was certainly been highly recognized recently. There's work that was a little bit different, well, a different perspective and twist on it was coming off of Weitzman. I think got a fair bit of attention. I think they left the door open for a lot of important questions. I think that it also, though that initial research also put on the table skeptics, I mean, very intelligent commentators, in fact, even participants to issue warnings about the limits of these type of modeling exercises, like don't expect too much, and here's why. I think of this like people like Granger Morgan's, treatise on this as well. That this isn't something that we're going to tell you the answer. Here's the precise answer. Go implement it in all policy situations. That's not really the state of our knowledge in this area. But I think having a both quantitative toolkit and a formal modeling framework and a conceptual framework for thinking about uncertainty, bringing those all together, we believe is important in terms of taking this whole line of research forward. So as Mike mentioned, there's these kind of two different pieces that interact. So the humans go and they emit carbon into the atmosphere. That plays out in the atmosphere, or plays out to the climate, now, a decade from now, many decades from now, and that plays out. So like, there's been work in geophysics about how that works, about how these human inputs can potentially have long-lasting and durable impacts on the climate. And there's some quantitative evidence to draw on. It's not super precise evidence, but there's some quantitative evidence to draw on, which we're very much trying to do. And then there's, once the climate changes, okay, well, what are the economic and social consequences? There may be very adverse ones, but also human beings adapt. They adapt to changes in their environment. And so how do you capture that adaptation as well in order to really assess what the long-term costs are? And while I see some gaps in the geophysics side, I think there's even more important gaps on the economic damage side. We've scratched the surface on thinking about, well, suppose we change the environment, what are the consequences of that going to be going forward?
One of the issues that we tend to talk about a lot when we're thinking about this is that we have these nice climate geophysics models that tell us something about what's going on. We have economists putting together economic models that take this into account. What's hard to model, though, is sort of what we haven't yet experienced, right? This idea of adaptation, what's so hard about that is that we haven't really seen the types of climate change that we might expect they're going to have to adapt to, people, individuals in these models. And we haven't quite experienced the level of climate change that these climate models are trying to capture and reproduce the outcomes that can be experienced. So I think sort of on top of that, other than sort of there's these responses that we have to get at, there's also this unclear kind of uncertainty about how that's going to look. Do the models that we have that seem to fit what's going on now, do they tell us much about what's going to be happening in 10, 20, 50 years when the responses are beyond sort of the observed outcomes that we're currently facing or that we have faced in the past? I think one of the places where you can see this is that there's been this really great climate science work within by H. Damon Matthews, by McDougall, by a number of really important climate scientists who have recently put together sort of these estimates and approximations of this transmission from emissions to temperature and how severe that can be. Now, if you look at sort of the scale of where we're at now, the differences between the different model estimates that they've been looking at are not that spread. They're fairly close, and so you could imagine that uncertainty kind of at this point in time, if you were just thinking about it, wouldn't be so critical. But as you go out over time, you'll see that there's this increasing divergence in how severe the amount of climate change can be based on all these different models. Essentially, they're trying to proxy for the same thing, but you see that each model gives you different outcomes, and over time that can become very severe. I think that's sort of one of the points that we really want to capture, is that if you're an economic agent and you're within a model and you want to think about uncertainty, it's not enough to just say, here's what's happening now, doesn't look so bad. It's that over time, these differences get much larger. And so you have to take into account what are the future implications, how bad could this get, and how do I want to react knowing that there's this potential difference in what my outcomes could be from one setting to another setting.
So this first picture which we have here is just lifted straight out of this work by McDougall, and it shows you via this kind of histogram or density the variation across simulations of the climate sensitivity parameter. And this climate sensitivity parameter is for geophysicists kind of mid-level type response because they run their models out for many centuries. For economists, it's much more of a long-term response. What's going to happen over, 50 years or the like. I like to say for economists, if we're making guesses much more than 50 years, I wouldn't trust our models very much. But so there's different conventions there. But this figure here kind of shows you the type of uncertainties which you face. There's lots of variation in this climate sensitivity parameter, and so we need to integrate that formally into our analysis and see how much it matters. Now, if you look at this next figure, this kind of depicts some of the so-called damage specifications. This goes from how temperature changes affect the overall well-being of the economy. And in this plot, you'll see this region over modest temperatures where we've got these so-called damage functions that are just tracking each other. These functions are telling you kind of, roughly speaking, what proportion of output is lost through the change through the environmental degradation. Where they matter is further out here in the tails. And so what drives a lot of these calculations is speculation about where the damages might be really big in the future, and that impacts how you ought to design policy today. So there's uncertainty about those damage specifications, but those damages just could be quite severe, and that's what the plot's trying to capture.
I think, one thing is sort of this point that we keep coming back to is the idea that when there's uncertainty in the model, when there's sort of these unknowns in terms of the climate outcomes or the economic outcomes, one of the key things that we're trying to focus on and that we feel is important is not just to say, we have this outcome, let's look at different values and see how that changes it, but to literally allow sort of the economic agents in the model to determine, I have this, how do I want to respond optimally to this? What is the choice I want to make knowing that uncertainty exists? And so it's rather than just sort of giving them one simple outcome and saying respond to this, it's building a model that allows both the economic and climate uncertainties to be integrated into the decision process to allow them to respond and think about these types of outcomes that could play out in the future.
So what I believe we're adding here is this idea that there's these alternative components to uncertainty that are, we believe are potentially very, very important. You saw from this McDougall plot that there's differences across models, and so how do we weight that evidence going across models? That's one type of uncertainty. The Matthews style or McDougall style evidence comes from itself approximations, from rather substantial approximations. So we're also premising on this using models as approximations in which there's mistakes, and so that's another type of piece of uncertainty, which our quantitative methods are meant to try to assess and try to figure out whether those are important or not. And important has to do with how they translate into things like the social cost of carbon. So we show that thinking about uncertainty in these much broader terms has very important quantitative impacts. It's not just some esoteric discussion which we have. It's something that's really quantitatively potent. And while other people have speculated about these type of entities and done them in very simplistic settings, we're really trying to push this into a part of our computational toolkit for addressing important social problems. I wish we could solve all this paper and pencil, so to speak. I mean, old technology. In fact, we have a co-author, Buzz Brock, who does his best to push the paper and pencil as far as possible for this stuff. And there are some basic insights which one can get off of how these models work without all the computational structure. But once you start pushing this into and integrating a geophysics model inside an economic model, there seems a little computational methods become imperative, because even the so-called geophysics models we're integrating in now are highly simplistic and arguably way too simplistic. But we can't analyze on paper and pencil, and so these to get at these interactions between economics and the climate are just such that computational methods are the only way that we can see how to proceed.
To get at sort of the critical components about the features that we think matter, it's both sort of these integrating these components that are going to be critical, but it's also these interactions and sort of the non-linearities that they generate, right? Like, one thing we could do is simply say, let's make this model very simple, and let's allow this to be sort of very linear so that the outcomes are sort of almost completely tractable just by paper and pencil that we could solve out for. But you lose a lot of sort of the interesting and what we think are the exciting components, these interactions that matter, these potential for sort of non-linear adjustments or thinking about these future outcomes that could be very severe. If you want to capture those in a reasonable way, in the way that we're trying to do it, you miss a lot if you don't allow for the computational side of this. If you try and simplify that away, I think you miss some of the key outcomes that we have found to be most interesting and sort of most critical to the results that we're finding when we're solving these models.
This is a situation in which the evidence is not so overwhelming as to give you lots of precision in terms of the calculations. If you were to abstract from uncertainty, it would be way overstate what our knowledge base is. Would way over so for me, it becomes therefore essential to ask, does this uncertainty matter? I mean, one possibility is, well, yes, there's lots of uncertainty, but once we put it on the table for the type of decisions we're trying to make, it's that uncertainty is not very consequential. So the challenge here is to actually figure out when it's consequential and when when it might not be. There's a case which we went into at hunches that it could be very consequential, and we certainly have examples under which that's the case. But it's not always going to be the case that it's in all policy questions that the uncertainty component is the important one. But for this one, it was our hunch, and certainly some of our preliminary calculations where we are supporting that hunch that the type of uncertainties we've tried to convey in these plots we discussed earlier really matter for the answer. And pretending that we had that all resolved would just really misstate the knowledge base and potentially then give misleading advice in terms of policy.
Yeah, I think part of what goes on is that in this discussion about what's the right policy response or what's the right action, by taking or acknowledging that there is uncertainty, there's sort of this natural inclination to say, well, if we don't know what's going on, maybe we just shouldn't do anything until we understand better. And I think part of what we're trying to demonstrate is that just ignoring the uncertainty or taking a hard stance on one line or the other isn't necessarily the best approach. I think what we're saying is we can take into account the fact that it could be that there aren't as severe damages. It could be that it's much worse than we think. How do we properly take that into account and make the decisions rather than having to push a hard line? We say, we're going to build this in, we're going to think about it, and we're going to allow the model to help us understand what's the right way to approach that. I think as Lars was saying, it clearly shows that the best approach, at least from our modeling perspective, isn't to just sort of throw that out or ignore it and say, let's not react. I think what it helps us understand is that when you account for these features, it tells us whether or not it matters, but it also tells us how much it matters and if we should be responding now or if we should be waiting, rather than sort of having this open discussion. We have the structure and the frameworks to say, well, if you think it's there, let's address it and let's put it on the table, and the model will help us understand how much we need to think about that. And I think that's sort of really critical to the policy action is how much does it matter, and if it does matter, then what does that mean for outcomes going forward? And so it's an important feature of determining policy actions is this is there, what should we do to respond to it, rather than, well, it's there, let's just ignore it, or let's just not do anything until we know something better.
One can imagine going to a policy like this and say, well, we're just going to bring some geophysicists in the room and they'll tell us what they know. There's some economists in the room and they'll tell us what they know, and we just mix it together and out pops the policy. And it just isn't that simple in a sense of you do have to have a type of interdisciplinary perspective on all this, I think, to be very successful. But you have to do it in a more integrated, thoughtful way, and because the interactions and the nature of those interactions and the natures of the uncertainties don't, they kind of interact and compound on you and the like. And so we really think that these are situations in which, yes, policy wants to draw on insights from various different sources, but to really do that in a sensible way, you've got to have some type of integrating framework to bring it all together, and that's what we're about.
So I think probably the easiest way to define it is just sort of the dollar cost of emitting another unit of emissions into the atmosphere, whether that's carbon or CO2. It's just how costly do we think it is from a social perspective, from sort of the government's perspective, or sort of this planner who's looking out for the outcomes of the individuals in an economy. How costly is it to produce another unit of emissions and put that in the atmosphere, knowing that that's going to have climate impacts and potentially damage impacts? Now, the reason that's so hard is precisely sort of why we're thinking about this question, is that if you want to give a dollar amount, if you want to value how costly this is, you then need to know sort of what are the risks involved, what are the sort of potential outcomes that go into the future of these actions that you make. And that's sort of where uncertainty really plays a big role. We've seen that in a lot of asset pricing work. You see that if you want to price an asset, if you want to tell me how much a firm is valued, I need to know the risk. I need to know how much that's going to compound over time. And uncertainty plays a large, or can play a large part in how that matters. And so the similar concept plays out in these social cost of carbon outcomes. It's a price. You want to know how much it matters. Well, uncertainty determines a lot of what goes into how you discount those outcomes in the future. How much do you care about those, and how do I value those in sort of different states of nature or different possible situations that can play out both economically and in the climate sense as well.
So here's the tricky part of it, and here's where it kind of gets confused as well. So as Mike mentioned, this is a so-called price, but this is a social price. It's not one in which you kind of go read the Wall Street Journal or Financial Times and just piece together a bunch of existing market data. Part of the argument here is that climate creates the so-called externality, and the price you want is a price that takes into account that externality. And so it's not so existing market data is only a very limited use in order to figure out what the relevant cost is here. It can help us pin down overall components of the economy. It can help us provide some type of inputs, but we can't just kind of read this off of a bunch of existing prices. And so our calculations are necessarily model-based. Now, when you're computing prices, it kind of matters where you are in some sense. We're actually formally computing hypothetical taxes. If you wanted to implement, or if you wanted to go to the kind of socially efficient allocation, this would be the type of tax policy required to support it. Now, there's other ways to do this. You can say, well, I'm sitting here in my current situation, and I want to figure out how much to locally penalize people, or small amounts of changes and things, and that would lead to different calculations as well. And the confusion, and even about the social cost of carbon, is what exactly your conceptual framework is. Are you trying to compute these socially optimal Pigouvian taxes? If so, then you have to be careful that you have to be cognizant of the fact that the extent to which those are prices, they're prices at a socially efficient allocation and not necessarily the ones we observed. So the mapping between these constructs and the actual data we observe on prices is there's a gap there, and that's why models help you fill the gap. The way we see this headed, I think we've scratched the surface on this to some extent. We view this as an opening move and not the final move. Is with this computational toolkit, decision makers can now say, well, here's what I think here, and here's what I think here, and here much confidence I have about these different opinions. This is what I ought to do. It's kind of this mapping between certain types of inputs that tell us what prudent courses of action are. We don't see it. We don't see at the end. Yeah, the end game here is just producing some single number. Here's the social cost or trajectory. Here's the exact social cost of carbon or carbon trajectory, but rather as a way that you can explore as you change model ingredients what the consequences are, as you explore how you respond to uncertainty. Should society be cautious in the presence of uncertainty, or should ignore it? Those are going to matter in a sensible decision making, and we're providing the set of tools that help you think about how that matters. But it's still going to require sensible inputs. We're making in our own calculations what we view are interesting, sensible inputs. But at the end of the day, we want this to be a framework for thinking about policy in systematic ways, and not just some mechanical recipe for producing the policy outcome.
Yeah, I mean, that's sort of the critical to what we're trying to get at, is that it gives sort of a foundation of what else needs to be there, right? There's been a lot of nice work saying, how do we get the social cost of carbon? And as we've looked at that, we've said, is there something more that needs to be considered? Are there important considerations that aren't there yet? And so, as Lars was saying, this is one way to take a stab at that and say, we think that uncertainty matters, and here's how much we think it matters. If we're taking this from the perspective that we've had before, here's an additional step that should be considered. Now that's, again, it's going to open the door to saying, well, how much more uncertainty is there? Or how does that interact with other potential economic pieces that maybe we haven't included yet at this time? But what it does, I think, is provide sort of a stepping stone that can really push us toward, if we think this matters, if we think determining the impacts of climate change is a critical thing to study, then here's another piece that needs to go into the puzzle to help us really get a better picture. And it will help, I hope, spur sort of greater understanding, greater willingness to address the difficulties that haven't yet been addressed in a full way, and then lead us to think about more cases or greater sort of concerns that need to be addressed, and help provide the framework and the toolbox, as Lars was talking about, to really get at that. I think that's sort of where, at least I've been thinking about this, is that it pushes us towards getting a better picture of what's going on and addressing what are potentially sort of first order concerns or things that really do matter. And in doing that, it should help spur further sort of growth and further understanding of this question, to know what else matters and how does that interact with what we already understand, and how can we go forward with that.
And it should be clear, there are other computational teams that are that even preceded us on this, that have dealt with uncertainty a little bit differently, but in interesting ways. Like Young-Yang Kai and Ken Judd, and those people have produced a sequence of papers that we view as complementary to ours, but probably with some similar ambitions here as well. So it's good to get more people working along these lines.
Do you find that when you address uncertainty pertaining to this topic, others perceive it as you denying the fact of climate change?
There's kind of this knee-jerk reaction when you talk to people, especially outside of economics, about first you think, I'm doing work on uncertainty and the fact that we that we don't know the exact quantitative impacts of climate change and blah blah blah, and then they jump to the conclusion, oh yeah, so therefore you're just going to tell us not to do anything. That you're part of this climate denial conspiracy or whatever. And it's kind of, that reaction is a bit depressing, but it really is a fundamental lack of understanding of how so-called decision theory works under uncertainty. Decision theory under uncertainty doesn't give the recipe to say, well, always wait till you know stuff before you act. You may well want to act now because it may be lower cost to act now, even though you're uncertain, before you wait until you are certain, and the damages are close to catastrophic. So we feel that so it's at times there is this kind of, yes, you're part of this climate denial conspiracy, but we do our best to correct that as quickly as possible.
Yeah, I think a major part of what we really want to do, and something that I think we're adding to this sort of study of how much climate change matters, is trying to really take seriously what climate scientists are doing. Like an essential component of our analysis is to take the work that's been done by climate scientists, take their research, take their estimates and their models, and integrate them as best as we can into an economic framework. Now, so I think the focus then is not to say like this is our stance or here's what's going on, but to take sort of the best possible research that's been done, take the best possible analysis that we can find from climate scientists who have been analyzing and thinking about this question and know obviously far more about climate change than we as economists do, and to take that as an input and say, given what they know and given our understanding, how can we quantify that? How can we understand that? And I think that's sort of a critical feature of studying climate economics, is to really take seriously what climate scientists have done, and then to try and build an economic model that sort of approaches that bar in terms of, here's a serious work that's been done in this climate and geophysics world, and let's build an economic model that will help us take this into account and use and build off of what's being provided. So in that sense, I think the questions can exist, but like if you look at sort of the heart of what we're doing, it's focusing a lot on taking what climate scientists know and don't know and trying to use that in the best possible way as economists to do what we know, which is how to value and think about economic decision making.
I think the University of Chicago is a place that's had high intellectual standards. It's been valuable for scholars like myself to kind of encourage you to kind of pursue what you think are important questions, to not have to come up with your answers tomorrow, and quick fixes. You're allowed to take thoughtful approaches, ways that probe, and maybe even take in some sense gambles in terms of your approaches to research. So I think overall that's been important. It's been an important tradition of Chicago economics, I believe, one that I've always valued. The other type of support we've been getting is computational support. We've been very the university computing people have been happy to help us think about better algorithms, better solutions. They're all on board to want us. They're pleased they're trying to use these methods to address important questions, and so we're very we've gotten much out of them. So. Myself, over the course of the last couple of years, I've invested much more heavily in computations than I had previously in my career, and their support's been vital to make this happen.
Yeah, from my own experience, I think Chicago's been just a great place in terms of the interaction, right? There's this sort of necessary interdisciplinary component to what we're doing, which requires sort of this applied math and computational support. It requires this interaction with geophysicists and climate scientists, and we've had a lot of interactions and support that have been really great. And again, from my perspective, I think Chicago, sort of the thing that I've always noticed is that when you go to present your research, when you go to get feedback, you sort of leave everything at the door, and it's this sort of push for rigor and quality academic research is what I've always found, is that there's been a lot of excitement and interest, mainly because it's this idea of pushing the frontier of what we understand and really trying to determine from a rigorous perspective how this matters and how much does it matter and how can we really make that better. So I've really enjoyed that at my time in Chicago because it's an environment that really fosters that first and foremost, the thing that seems to always matter when I discuss with faculty or when I present research or when Lars and I are getting feedback has always been, from an academic perspective, let's make this rigorous and let's make it serious and let's think about this from the best possible way. Rather than sort of being driven by opinions, it seems to always be let's put the research first and really make it rigorous, and then we can determine how much this matters and how important that is. And that's something I've sort of, as a graduate student who's been here, have seen that at the front of everything that's been done, is that it's what matters is the research and how well are you doing it, and how can we best address this question? And that seems to always come to the forefront of everything, and so I've appreciated that. It's something I really valued and noticed has sort of been a central component of the work that's done here at Chicago.
Relative to most graduate students, Mike is a little bit special in the sense that he's quite eclectic. he cares about computations, he cares about finance, he cares about addressing important problems, and he's been kind of a pleasure to work with just because of his own broad interest and kind of good ambitions. And so I think in many respects he's been ideally suited to exploit the strengths of the Chicago economics environment.